So we have h of x and k of x, which are two different functions. And here we are required to find the composition of the inverse of h and k. All right. So of course, k of x, we have it. What we don't have is the inverse of h. So step one, find the inverse of h. So step one, find the inverse um, of f of x. So, sorry, inverse of h of x. So the first step here will be we replace h with y. So we'll have y is equal to x plus 4 over 2, which implies that, and then you switch x and y. So x, uh, actually I can just write, so x will be equal to y plus 4 over 2. Make y the subject, so y, so we have 2x will be equal to y plus 4, which means y will be equal to 2x minus 4. So the inverse of h will be 2x minus 4. But now, what we want to find here is the composition of um, h and k. So we want, so step 2, find the composition, which is basically h of k of x. Now, obviously, you can see here what's happening is we need to plug k of x, or the output for k of x, which is 3x minus 5, into the inverse of h in place of x. So this 3x minus 5 goes here in place of x. So what we'll end up with is h k of x will be equal to 2 into 3x minus 5 minus 4. And that will be equal to 6x minus 30 um, minus 10 minus 4, which will be 6x minus 14. And that will be the required result. So that's basically how you work out part A. For part B, um, we are required to find the composition of H and itself. So basically, what we are required to do is to plug the results of H into H in place of X. So if you plug this, which is that, in the same function in place of X, so we'll end up with X plus 4 over 2 plus 4 over 2. Now, obviously, you can notice that this here is the same function. And what I've done is just to plug the same function into the same function in place of x. And that's what we end up with here. Now, of course, I mean, that's basically what it is, but I'll just go further and simplify that expression. So this is the same as x over 2 plus 4 over 2 plus 4, all this over 2, because each of this is divided by 2, and that's basically what I've done. Now 4 over 2 is 2, and 2 plus 4 will be 6, so we have x over 2 plus 6, all this over 2. Now here we are dividing everything by 2, so x over 2 divided by 2 plus 6 divided by 2. Now if you divide a half by 2, you end up with a quarter. X over 2 divided by 2 is same as x over 2 multiplied by half, which is basically x over 4, and that will be 3. And that will basically be your result in this case. Okay, number 5, f of x is given by that, and we are required to find the composition of the inverse of f and f, which means here we have first of all to start by finding the inverse of f. So step 1, we can start by finding inverse of f. So step 1, find the inverse of f. So the inverse of f here, we start by replacing y with f of x. We have y is equal to 2x plus 3. Interchange x and y, so x will be equal to 2y plus 3. Make y the subject. So x minus 3 will be equal to 2y, which means y will be equal to x minus 3 divided by 2. And that will basically be the inverse function. Okay, and then step 2, we find the composition of the two functions, which is the composition of the inverse of f and f. Remember here you're plugging that, which is basically that function there, yeah, in place of x in this function. So I'm just gonna take this out anyway. Yep, so what we shall end up with here is so if we plug this, which is 2x plus 3, into this function in place of x, we'll end up with 2 plus 3 here, yeah, minus 3 over 2, which will be equal to 2x. Well, actually, this will be equal to 2x over 2, which is just equal to x. So this will be equal to x. And that will be the final result. Now here, we already have the inverse and the original function. Here we're plugging the inverse into the original in place of x. So we are basically finding now if you notice here, this is the output of the inverse, which is basically that, and that's what's being plugged into this function in place of x, into the original function in place of x. So if you take this and you plug it here in place of x, you'll have 2 into bracket x minus 3 over 2 plus 3. And now, I mean, this cancels, so you end up with x minus 3 plus 3, which is equal to just x. Now, what does this mean? I mean, you've seen here that we have found the composition of f and its inverse, f and its inverse, and in both cases, we are ending up with the same answer, x and x. What does this mean? So first of all, what I've just said is that notice that the composition of the inverse of f and f is the same as the composition of f and its inverse. And all this is equal to x. So this is a true statement. All this from what we've just observed, all this is equal to x. So this means that each function, yeah, reverses the effect of the other. So by finding the composition of f and its inverse, like cancelling, you do and undo, you end up with where you started, which is x. So basically, this means that each function reverses the effect of each other. So this means each function reverses the effect of the other. And that makes sense because an inverse function reverses um, the results of the other function. Yeah. If the other function multiplies by 3, the inverse function divides by 3. So you end up with the original values that you started with, which is represented by x in this case.